This is Miss Bruin in the virtual lab, and I wanted to create a video today to support your research on geothermal energy. So, this video is just going to explain a little bit more in depth what geothermal energy is and how we can use it or harness it in order to help power our homes and our world. So, geothermal energy requires that we go back and think about what our earth is made up of. So if you think back to your geology unit or your rock unit, you probably learned that underneath the crust of our earth, which is the continents and the ocean floor, right? The outermost layer is called the crust. And underneath that, there is something called the mantle. And that mantle is full of hot magma, right? And we see some of that magma bubbling up to the surface of our earth when we see volcanoes explode. Or you might see a dormant volcano releasing steam, right? So all of these places are these volcanic areas are little windows into what's really going on deep below the crust of our earth or the outermost layer of our earth. So, in summary, geothermal energy is that energy produced by the heat that is transferred out from the Earth's interior, from the insides of that Earth where that bubbling mantle um, is. So we can tap into that heat, and most places that use geothermal energy are found near areas where there is volcanic activity. So, when we discuss geothermal energy technologies, there are a couple of options. So, with option one, what engineers and surveyors will do is you have to spend a lot of money on getting your land surveyed, having it tested to see how far down the heat is from the crust, from the surface. And so what happens is if your land is deemed viable for this kind of energy source, they will drill a well and they'll pump down into the well water or some kind of liquid. And from the surface where that cold liquid is pumped down, it will be pumped down until it gets to a point where it's hot enough that it will be heated up. And the heat from the inside of the earth is used to create steam. So that liquid is heated up and creates a steam, and that steam can be used in different ways inside of a house. For option two, humans can utilize hot springs and geysers. But you have to keep in mind that these phenomena are uncommon and can only be reached in certain locations where the heat from the mantle is very close to the Earth's surface. Again, if you're a neighbor to a volcano, this may work. And that's why you see a lot of communities built up near volcanoes. It might seem silly or it might seem dangerous, but it also has many benefits. And so, if you want to know how geothermal energy really works, and this can be used on a much larger scale near hot springs and geysers. So, what happens is a geothermal plant they'll pump down they'll create an injection well, just like in a residential house, and they'll pump down cold water. And they'll pump it down to some very hot areas, and that water will heat up and cause steam to come out from the other well. And so they create like a cycle. And that steam will push a turbine, which will ignite a generator that then converts that thermal energy to electrical energy, and it is connected to the electrical grid so that a community can get electricity. Um, and then it will recycle the water back through, and it will let out that steam and cool off that water. And that water is ready to go down and create another cycle of energy. Um, what's very cool about this kind of energy is that that magma is always there. That thermal energy that's inside of our earth is always there. So it is renewable and it doesn't create any kind of pollution or smog. A lot of times when you see some kind of plant like this, it looks like there's pollution, but all that is steam from the cooling towers where that water is being cooled off. I wanted to share with you a story about a little island in Iceland because it's leading the way in geothermal technologies. And part of that is because of where it's located. So, the United States, let me get my highlighter out here. The United States is, if this map continued, it's somewhere down here. Um, so Iceland is our neighbor up to the northeast, moving up toward the Arctic. And um, the cool thing about this little island is it actually sits on something called the Mid Atlantic Ridge. So, down throughout the Atlantic Ocean, at the bottom of the ocean, is a seam between two plates. So, on the crust, there are these plates that move around. You may have learned a little bit about this in an earlier unit. So, there's this North American plate and this Eurasian plate. Um, and what they're doing is they're separating from each other. And so as they separate, literally, the earth is cracking open, the crust is cracking open, and that magma down below in the earth's mantle is moving up closer. So they can tap into, they have tons of volcanoes on this fault line, as you can see, these little triangles represent the volcanoes. So they have a bunch of different areas where they can capitalize and use some of this geothermal energy that's coming out from inside of the earth. This is actually a geothermal energy plant and a huge hot spring that people benefit from. They can go swimming in, and there's mineral rich waters coming out of it. So I think that this technology is just beginning. And if we could do some mapping, do some surveying, and figure out some places where we can use it, we could definitely utilize it in the United States of America as well. Thanks for listening, scientists. I hope you learned more about the geothermal technologies that are out there.